Welcome everybody to this second meeting of the One World Cognitive Psychology Seminar in the spring term 2021. Today, I'm pleased to announce one of the most renowned and most influential working memory researchers worldwide, Klaus Oberauer from the University of Zurich. As usual in our seminar series, let me start with a few words about the speaker's academic background. Klaus Oberauer received his education as a psychologist at the Free University Berlin, where he finished with a master's degree in 1991. He then went to Heidelberg University to earn his PhD in 1995, and later on to the University of Potsdam, where he obtained his postdoctoral lecturer qualification in 1995, the Habilitation, as we call it in Germany. Already at that time, he was deeply involved in problems and advances of working memory research, as reflected in his publications of those years, and also in his habilitation thesis, which was entitled Limits of Cognitive Capacity, Why We Are Not More Intelligent. In his doctoral and postdoctoral years, Klaus held research scientist positions at the University of Mannheim, at the University of Potsdam, before he received a call on a professor position at the University of Bristol in 2005. After another 4 highly productive years, he received a further call to the University of Zurich in Switzerland, where he has worked as a professor since 2009. Klaus' scientific oeuvre impresses not only by the sheer amount of publications in the best journals of cognitive psychology. He has currently about 175 published papers, plus almost 20 contributions to edited books. He impresses even more by his important and influential contributions to both empirical research and theory building in working memory and reasoning research. His outstanding scientific reputation is reflected in editorial board memberships for 8 leading cognitive journals, and in addition, in associate editor positions for Memory and Cognition, the Journal of Memory and Language, and most recently, the Journal of Experimental Psychology, Learning, Memory and Cognition. Since many years now, Klaus Oberauer has continuously received funding support as principal investigator from prestigious funding agencies like the German Research Foundation, the Alexander von Humboldt Foundation, the Economic and Social Research Council, United Kingdom, and the Swiss National Science Foundation. Notably, Klaus also received several honors and prestigious awards, like the Charlotte and Karl Bühler Award of the German Psychological Association in 2004, and the Mid-Career Award of the Psychonomic Society in 2019. Given all these impressive merits, one should not forget to thank Klaus for the fact that he also did a lot of service for the scientific community, not only as a reviewer and action editor for numerous papers submitted to cognitive journals, but also as a symposium organizer and as president-elect and later president of the European Society of Cognitive Psychology from 2017 to 2020. Dear Klaus, we are really happy that you agreed to present some of your recent research in our One World Cognitive Psychology seminar, and we all are looking forward to your talk, Incidental and Intentional Memory, a New Dissociation Between Working Memory and Long-Term Memory, ? I'm sure you will explain the question mark, sure. Klaus, the floor is yours.
Thank you very much for the invitation. Thank you, Edgar, for the nice introduction. Today, I want to tell you about incidental and intentional memory, and also a bit about directed forgetting in working and long-term memory. This is work that I've done with Werner Greve from Hildesheim. That's the friendly thinker that you can see here in the bottom. Our starting point was a functional analysis of these 2 forms of memory, working memory on the one hand and episodic long-term memory on the other. That is, we asked ourselves, what are these forms of memory good for, and what should they work like to fulfill this function optimally? For working memory, I think we can agree that its function is to hold information available for our ongoing cognitive processing. We also know that working memory is severely capacity limited. And given these constraints, to work properly, it needs to constrain its contents to what is most relevant for a current cognitive goal. And in order to accomplish its function, therefore, working memory would work best if it by default kept information only as long as it is needed, and as soon as information is no longer relevant, it's dropped as quickly as possible. Right? On the other hand, the function of episodic long-term memory is to maintain information from our experiences that we engage in cognitively for potential future use, for potential future encounter with similar situations. Also, for all we know, episodic long-term memory has no capacity limit. Now, it's very difficult to anticipate what information from our current experiences will maybe become important and relevant and helpful in the future. So for an episodic long-term memory to work optimally, it might be best to just keep everything that is encoded and not throw away any information that might be useful in the future. So this analysis translates into some predictions for the role of intentions, memory-related intentions in working and episodic long-term memory. Working memory operating by default on a policy to forget everything unless it has good reasons to maintain it. For working memory, we should expect that if we give people an instruction to remember some material, that should massively improve their ability to actually remember it a few seconds later, compared to an incidental memory baseline where we ask participants to engage with some material, but we don't mention any instruction about memory at all. Now, compared to such an incidental baseline, telling people explicitly to forget the material should not add or subtract anything from the incidental baseline level, because in the incidental baseline, they would forget it anyway, unless they have a good reason to remember it in working memory. So the idealized predicted pattern is depicted down here on the left. If we imagine we tested working memory with a task that only tests working memory. I don't know whether that exists, but it's a bit idealized. On the other hand, episodic long-term memory, we assume, works on a policy to, by default, remember everything that it has encoded. So giving people the instruction to remember some material should not add anything compared to an incidental memory condition where we don't give them any instruction pertaining to memory. In contrast, telling them to try to forget the material might actually weaken their memory traces relative to an incidental memory background. Although I put that in parentheses with a question mark, because the assumption that directed forgetting actually weakens memory does not follow from our functional analysis. One could argue one way or another. It might be functional to intentionally forget something, but given that it's so hard to anticipate what information might be useful in the future, one could also argue that from a functional point of view, episodic long-term memory might work optimally if its contents were protected even against the intention of the person. So this is a more an exploratory part of this endeavor. So let's first look into the literature, what we already know about these predictions. And on the side of episodic long-term memory, we know quite a bit. The contrast between intentional and incidental memory has been studied many decades ago. This is a classic study by Hyde and Jenkins, a slide that I show every year in my cognitive intro lecture. Hyde and Jenkins gave participants a list of 20 or so words, and they gave them a so-called orienting task to make sure that they attended to and engaged with these words. And one group of participants received an orienting task, the task to judge these words for their pleasantness. So that's what later has become known as a so-called deep encoding condition, because it orients people towards the meaning of the words. Other participants were asked to just decide whether the word contains an E or count the number of letters of the words. These are more superficial orienting tasks. And in addition, each of these orienting task groups was split into subgroups. One half was given the additional instruction to try to remember the words. That's the intentional condition. And the other participants weren't given no memory-related instruction. For them, the subsequent memory test came as a surprise, but still, with a pleasantness orienting task, the so-called deep encoding assignment, memory in the incidental and the intentional group was comparable. So if we make sure that at encoding, participants encode the material optimally, the deep encoding condition also happens to lead to the best episodic memory. Under these optimal encoding conditions, the intention to remember something doesn't seem to add anything to the ability to recall from episodic long-term memory. Now, the instruction or intention to forget something also has been studied extensively in episodic memory with directed forgetting studies. And I'm going to focus on the list-wise directed forgetting paradigm because that's the one that we're going to use in a variant later in our experiments. In this paradigm, a control group, what I call the remember group, is first given a list of words to remember, list 1, and then given another list of words, list 2, and then they're asked to recall the words from all these lists together. The experimental group, what I call the forget group, is also given a first list of words, and then the experimenter tells them, oh, look, sorry, this was a mistake, this was the wrong list, forget that list, I'll give you a new list, and then they study list 2. And then, surprise, surprise, they are asked to now recall words from both lists. Right? Now, this typically leads to successful forgetting of the first list. So you see here, that's data from Bernhard Pastetter. The forget group is less successful in recalling the words from the to be forgotten list 1 compared to the remember list. And that pays off in that they can recall the list 2 words a bit better. So directed forgetting seems to work in episodic long-term memory. Now, turning to working memory, the contrast between intentional and incidental working memory apparently hasn't attracted the attention of working memory researchers before, so we have nothing to build on here. But directed forgetting has been studied quite a bit in working memory. I've done some of these studies myself, but today I want to show you just one older study from Neuter, which in fact he hasn't even framed as a directed forgetting study, but I think that's what effectively it is. So Neuter built on the classic Brown-Peterson paradigm. So he asked people to remember letter trigrams like FKT. And then in 78% of the trials of his experiment, this was just followed 2 seconds later by a recall instruction, and then people recalled these trigrams. In most of the remaining trials, 17% in total, the initial trigram was followed immediately by a 3-digit number. And in that case, participants were to count backwards in steps of 3 from that number. And they were not tested in these trials for the trigram. So they learned in the experiment that whenever they saw a 3-digit number, that effectively meant they could now forget the trigram. Except cheeky Neuter inserted just 2 trials, most of them later in the experiment, where after that 3-digit number and participants' initial backward counting, 4 seconds later, they received a surprising recall test. Right? By now, they probably have tried to forget these trigrams because they just get in the way of the backward counting. And in fact, it looks like they were very successful in that. So this red dot here that you see at 4 seconds delay, that's their level of recall of the trigram that they were supposed to forget. Right? And the blue line, that's for comparison, just data from a standard Brown-Peterson paradigm from another experiment, where, of course, people also, after receiving a trigram, engage in backwards counting, but then they have the intention to still remember the trigram. And, well, they're not perfect, but they're way better compared to when they intend to forget it. So this looks like, contrary to my prediction, directed forgetting also works quite well in working memory. But then keep in mind that these directed forgetting studies always compare an instructed forgetting condition to an instructed remember condition. What we don't have in directed forgetting studies is what I call the incidental baseline condition, a condition where people are asked to engage with the material but are not given any memory-related instruction at all. And I venture that if we had an incidental baseline in the working memory test, performance would align with the intentional forgetting level like here, right? Because I assume that working memory by default gets rid of information as quickly and efficiently as possible, unless it has a good reason to keep it. So these are the predictions that Werner and I set out to test. And in the first two experiments, these were two pretty much parallel experiments. In each of these experiments, we compared a typical working memory test with 5 word lists, memory tested with an immediate recall test. We compared that to a typical episodic long-term memory test where people received 25 words and their memory was tested after a 60-second delay filled with a distractor or filler task. In this case, this was mental arithmetic, which is very often used in this research tradition to try to minimize any contribution from working memory to people's recall. Now, different groups of subjects at the beginning of the experiment received different instructions. One group received the instruction to, in addition to doing the orienting task on the words, also try to remember these words. Then another group, that's what we call the incidental group, received no further instruction pertaining to memory. They were just told, do the orienting task. And then we had a third group, which we told, try to forget as soon as you're done with the orienting task, try to forget these words to clear your mind. And well, the two experiments only differed in the orienting task that we used. In the first experiment, we used a standard semantic, so-called deep orienting task. People were asked to decide whether the object that each word referred to was larger or smaller than a soccer ball. In the second experiment, we used the famous Savannah survival scenario that Nairn and Pandarada introduced a few years ago, simply because this is known to be one of the most effective orienting tasks in terms of establishing episodic long-term memory. So with this orienting task, we wanted to make sure that people's processing during the encoding period was optimized, at least for episodic memory, so that if people were able to remember even more when they intended to remember compared to an incidental baseline, that additional boost of memory from the intention to remember could not be explained by saying, well, with the intention to remember, people engaged in even better encoding processes, elaboration processes, because we already optimized the elaboration process for them through the orienting task in all instruction conditions. That was the idea. Now, let's have a look at what these tasks looked like for participants. First, the working memory test. People went through 5 trials of the working memory test, and the first 4 trials looked like this. They received, across a row of 5 boxes, they received the words one by one, gave their judgment on, say, whether a horse is larger or smaller than a soccer ball. Immediately upon pressing a key, they saw the next word, made the same judgment, next word, next word, next word. And after the last word, depending on the instruction condition they were in this case, if you were in the remember condition, you would be actually tested on this list, recall the words, and then participants would receive a column of 5 boxes. They typed the words, and then they appeared in these boxes. Now, in the incidental baseline condition, there would be no test in the first 4 trials. Participants would just be told to please wait for about half a minute, about as long as the remember group needed to actually recall the list. So we wanted to equate the interlist time between instruction groups. And in the forget instruction, they received a reminder to now try to forget the last 5 words to clear their minds, right? Okay, now in the 5th and final trial of the working memory task, after making their final judgment on here, pill, all the groups, regardless of the initial instruction that they had received, are now asked to remember the last 5 words, type them in any order they liked, and they would receive this column of 5 boxes into which they could type their words. So this memory test now would come as a surprise to those participants who were in the incidental or the instructed forget condition. Okay, they typed their words, they appeared in these boxes, and then in this final test, we also wanted to know how well people remembered where in the list they had seen each word. So after they typed the words, they saw another instruction to please now, for each word, click in the original box in which they think they have seen that word. So the response words would be highlighted one by one, and then people clicked on one of the boxes where they thought they had seen planet. Then P is highlighted, and they clicked on another box where they thought they had seen P. Okay, that was the working memory test. The episodic long-term memory test, that was a single trial for all participants where they saw 25 words across 5 rows of 5 boxes. On each word, they gave their judgment according to the orienting task, P, and so on for all the words. Finally, desk. And then, depending on the instruction condition, they got an initial reminder of their original instruction. For instance, in the forget condition, they would again be asked to forget the words. And then they received an instruction to do the arithmetic task. And then they worked through a number of these arithmetic equations. So in this case, they would have to type 12 as a response. Immediately upon typing that, they received the next equation and so on for 1 minute. And then everybody received the instruction, please try to remember all the words, or as many as you can, right? They received 2 columns of boxes into which they could now type the words. If they couldn't recall anymore, they had to type end, and then the trial ended. Okay, that's what that looked like. Now, before I show you the results from the first experiment, a brief words about the methods of all the experiments that I'm going to go over today. All the independent variables were manipulated between subjects. It had to be between subjects, because when you do an incidental memory test or even an instructed forget test, and then you have a surprise memory test at the end, well, you can do that with each person only once, right? So we had to manipulate everything between subjects, which of course means we needed lots of subjects, typically for no more than 5 or 10 minutes. And we found them online on Prolific. So we aimed for about 100 participants per design cell in each experiment. After some exclusion criteria, we ended up with 70 to 100 or so. The most important exclusion criterion was that in the incidental and forget instruction groups, we asked them at the end of the experiment, did you maybe expect the memory test? And everybody who said yes to that was excluded. We analyzed the data with Bayesian general linear models with the base factor package by Morey and Rauder. And in all the plots that I'm going to show you, the error bars are 95% confidence intervals. And here is the first plot. So this is experiment 1 in the left panel and experiment 2 in the right panel. Fortunately, the pattern looks pretty much the same. On the x-axis, you see on the left, the working memory test, on the right, the long-term memory test. With the working memory test, we see that instructing people to remember improves their memory substantially compared to the incidental baseline. With a long-term memory test, that's not the case, just as we predicted. The instruction to forget did nothing. This is going to be a recurrent theme throughout all the experiments that I'm going to show you. The instruction to forget never had any effect in our eyes. Right, so what you're seeing here is our first and primary measure of memory. That is just a proportion of words that people could recall. That's what they were told to do initially. But then we also had a second index of memory coming from that follow-up test, where we asked them to now try to remember the position of those words that they could recall. So this is the probability of getting the position right, given that they were able to recall an item. And this in this experiment shows exactly the same pattern as the item recall. All right. Now, one thing that you might wonder about at this point is, could it be that when given the instruction to remember, that people just took more time for each of their responses in the orienting task, thereby gaining longer encoding times? And you're right, this is the case. In this experiment, this is experiment 1, but that's the case for all the experiments of this series. Participants in the remember condition took a bit more time, some 200 to 400 milliseconds on average, for each orienting task response. And that's why we included their mean response time as a covariate in all the models. And all the effects that I'm going to describe are still statistically supported after controlling for latency. Okay, so what have we learned from the first 2 experiments? Our predictions were largely confirmed. The intention to remember improves a test of performance in a test of working memory, but not in a typical test of episodic long-term memory. The intention to forget had no effect on working memory as predicted. It also had no effect on episodic long-term memory. And that doesn't really clash with our predictions, but it does clash with a long literature on directed forgetting, which suggests that the instruction to forget has a detrimental effect on long-term memory. As I said, we never find that. And in the end, I'll come back and try to give you an explanation for that. But for now, I want to highlight that our contrast of a typical working memory test and the typical long-term memory test involves 3 important differences between these 2 kinds of tests. And in the remaining experiment, we're going to unpack these differences. So these are, first of all, the working memory test always involves an immediate test of memory. The long-term memory test involves a delay, a filled delay. The second difference, of course, is that the working memory test has a much smaller set size or list length. And the third difference, maybe a bit inconspicuous, is that in a typical working memory test, participants are given many, many trials one after another, potentially building up a lot of proactive interference. Whereas in many episodic long-term memory tests, including the first 2 that I've just shown you, participants receive a single list to remember. So at least within the experimental context, no proactive interference builds up for that list. Right? Okay, so the next experiments are devoted to looking at these 3 variables that separate working memory tests and episodic long-term memory tests separately and see which role they play for modulating the effect of the intention to remember. But first, I want to say a few words about proactive interference in the context of working memory. I started from the assumption from our functional analysis that working memory by default removes all information that is no longer needed. Now, one advantage, of course, of that is that proactive interference should not pile up within working memory because all the old material will just be thrown out. Right? And there's evidence for that from a study that I did a few years ago with a working memory updating task, showing that people are very good to efficiently update their working memory. So whether we ask them to update their working memory 5 times, say, or 10 times or 20 times, does not make any difference for their performance, their ability to recall the final contents in the end. So obviously, proactive interference does not build up in working memory. Recently, we have evidence that the contents of working memory are also very efficiently protected against proactive interference from long-term memory. So if you try to hold something in working memory and there is related information that you have in long-term memory, you could if you decided to recall that information from long-term memory, but you don't have to. It is not automatic. So long-term memory contents don't involuntarily intrude into working memory. Now, one consequence of that is that if we ask people to remember something, by our assumption, that should selectively boost maintenance in working memory, improve maintenance in working memory, that intention to remember should turn out to be most beneficial for overall memory when proactive interference is high, because then working memory can protect the memoranda against proactive interference. Okay. Turning to experiments 3 and 4, these experiments now contrasted an immediate versus a delayed test with a filled delay. We varied the set size, although all these set sizes are still in the range of typical working memory tests. And between these two experiments, we manipulated the level of proactive interference. So experiment 3 had a very low level of proactive interference because participants only did a single trial, whereas experiment 5 had a high level of proactive interference because participants did 5 trials, of which only the last one is the critical one on which everybody is tested for memory regardless of the initial instruction that they received. Okay. Otherwise, everything is just like in the first 2 experiments, so we can move directly to the results. This is experiment 3, a low proactive interference context. On the left, the immediate test. On the right, the delayed test. Result can be summarized very quickly. The only effect that we see is the good old effect of set size or list length. Of course, with larger lists, memory gets worse. Otherwise, the instruction conditions did nothing. This is for item recall, but we see the same for the probability of recalling the position given that an item was recalled. Now, turning to experiment 4 with a high proactive interference context, now things look different. With an immediate test, we get a beneficial effect of the intention to remember relative to the incidental baseline and also the forget condition. We see that for all the list lengths. But we do also see for item recall a bit of a beneficial effect of the intention to remember in a delayed test, where actually I didn't really expect that, but we see it but limited to list length 3. So what I suspect what's happening is that despite our efforts to pretty much eliminate any residual traces of the words in working memory by 1 minute of mental arithmetic, maybe that arithmetic task is less effective in doing that than the community used to believe. And so when the working memory load is small with just 3 words, some still useful residual traces of those words might have survived in working memory. Now, looking at the probability of recalling the position, given that you have recalled an item, in an immediate test, again, the intention to remember boosts memory for all list length. But now we also see that boost for the position memory at the delay in the delay test for all list lengths. Right? And so this is the first time that the position memory score seems to give us a bit of a different pattern compared to the item recall. Now you might think, well, this is just a fluke, but I tell you it's not. There will be more of this. We will see this more often in the upcoming experiments, that position memory in some regards responds differently to the remember instruction than item recall does. All right, so what we learned from these 2 experiments is that the level of proactive interference really matters. When proactive interference is low, as in experiment 3, then it looks like episodic long-term memory can essentially do the job of remembering. And intentionally maintaining the words in working memory, as we assume happens only when people are instructed to do so, does not seem to add anything to people's eventual recall success. In contrast, when proactive interference is high, then episodic long-term memory suffers. And then the intention to remember, motivating people to, in addition, keep the information in working memory helps a lot. Okay, so far so good, but in these two experiments, we manipulated the variable that turned out to be the most important, namely the level of proactive interference between experiments. So we thought we should do our homework, replicate that effect within a single experiment. That's the purpose of experiment 5, which now focuses on set size 5 only. Again, contrasts an immediate test to a delayed test and has the two levels of proactive interference within an experiment. And of course, again, the 3 instruction conditions. All right. Here are the results for the item recall test. And with an immediate test, we see what we saw before and also what we predicted. When proactive interference is low, the intention to remember adds nothing. When proactive interference is high, so here on the right, then the intention to remember matters a lot because it effectively protects the words against proactive interference, whereas in the incidental baseline and with instructed forgetting, proactive interference substantially impairs recall. With a delayed test, we see, again, quite substantial proactive interference. We still see a bit of a effect of the instruction, the intention to remember, to improve memory, but it's not strong enough to really protect the words against proactive interference. Looking now at the position memory score, immediate recall on the left, it looks same pattern. Again, with high proactive interference, the intention to remember protects memory against proactive interference. In the delay test, we also see, in this case for the position memory, we see more convincing evidence that the intention to remember still helps position memory even at a delay test in both low and high proactive interference. Although with low proactive interference, the evidence is not quite convincing. But high proactive interference is clearly there, even with the delay test. All right, so with an immediate test, the results confirmed our prediction, maintain the words in working memory, protects them against proactive interference. But against our expectation, we do see still some effect, some beneficial effect of the intention to remember at a delay test. And another thing that surprised me quite a bit is I want to draw your attention to the fact that when you compare the overall memory accuracy level between the immediate and the delayed test, there is hardly any difference, right? So 1 minute of mental arithmetic decreases memory accuracy by barely 3 to 5 percentage points, right? This is much less of an impairment than we would expect if 1 minute of mental arithmetic completely wiped out working memory, right? So this further fueled my suspicion that a mental arithmetic task might not really engage working memory to such an extent that there's nothing left in working memory from the preceding words. And so to follow up on that suspicion, in experiment 6, in experiment 6, we repeated the previous experiment's high proactive interference condition. We focus on high proactive interference because that's where we see the beneficial effect of the instruction to remember. And now again with immediate and delayed test. But here in the delayed test, we replace the arithmetic task by a new filler task, an alpha span task, which is a very demanding working memory task. Participants on each trial of that alpha span received 7 letters, and they had to recall the letters not in the order given, but in alphabetical order. So to give you a bit of a flavor of what that looks like, watch for the following series of 7 letters and try to reorder them in your working memory in alphabetical order. Oh, that animation didn't work. Oh, sorry. Looks like Zoom doesn't allow me to do this animation. Okay, imagine you see 7 letters at a fairly quick pace, and then you have to reorder them alphabetically. Right, okay. Here's the results. On the left, that's item recall. and we see essentially what we saw before, a beneficial effect of the instruction to remember at the immediate test. At delayed test, it's much diminished, and although we still see it numerically, the statistics, the base factor actually provides more evidence against that effect in the delayed condition than in favor. In contrast, position memory now clearly behaves differently. Position memory shows a clear and convincing beneficial effect of the instruction to remember, regardless of delay. So even with a delay filled with a very demanding working memory task, the instruction to remember seems to still help position memory, though not item recall. Okay, that was a bit unexpected and against our predictions. And so in the final two experiments, we followed up on that. And we now took a different approach to focus on episodic long-term memory by increasing the set size. Right? Now we gave people, again, 25 words, way more than by any capacity estimates can be held in working memory. So here we can be pretty sure, even if our filler tasks maybe are not as effectively as we hope to, we can be pretty sure that only a small minority of these words could possibly be recalled from working memory. Again, we focused on the high proactive interference condition because that's the only one where we ever saw a beneficial effect of the instruction to remember. And we did, again, an immediate and a delayed test. Right, here are the results. On the left for item recall and on the right for position. For item recall, this time we clearly see no beneficial effect of the instruction to remember on item recall, not at the immediate and not at the delayed test. In fact, we see a tiny but consistent detrimental effect now of the instruction to remember. And well, I couldn't really believe that, and that's why I wanted to run an replication experiment, and that's what duplicates. Right? We don't really know what that means, but clearly there is no beneficial effect whatsoever of the instruction to remember. Turning now in the right panel to position memory, here we see a very big positive effect of the instruction to remember in the immediate test, in the delay test, and it replicates. So clearly here, position memory does not reflect any traces from working memory, and yet it benefits from the instruction to remember. That was quite surprising. Yeah, this is basically a summary of this fairly surprising pattern of results. I suspect that the intention to remember has two effects. One is to give people a good reason to maintain the information in working memory. And the other seems to be an effect on episodic long-term memory, which I hadn't anticipated and nobody had described before. What we also see, once again, we saw that across all the experiments, the intention to forget didn't have any effect in our hands. So, interim conclusion, what we learned so far from these experiments is the intention to remember seems to have different effects on a test of item recall and the test of position memory. The effect of the instruction to remember on item recall fits exactly the pattern that we would expect to see if this boosted selectively maintenance and working memory. We see this effect only when proactive interference is high. That's where working memory can really help a lot. And the set size is small enough so that most of the delay is filled by an arithmetic task, which might not really wipe out working memory completely. By contrast, the beneficial effect of the remember instruction on position memory clearly seems to improve item context bindings in episodic memory. We also learned a few things about the intention to forget. Simple result pattern, no effect. But that seems to clash with the well-established forgetting DIFO effect in list-wise directed forgetting studies. Now, one thing to bear in mind here is, again, in classical directed forgetting studies, the contrast is always between a forget condition and an instructed remember condition. Whereas here we focus on the forget instruction and an incidental baseline. Right? But then in all those experiments and conditions of this series of today that approximate the typical test of episodic long-term memory, we always saw no effect of the remember instruction, at least on item recall either. Right? So even compared to a remember instruction, we didn't see that a forget instruction makes memory worse. So to explain that, Bernhard Pastatter's work came to our help, because he discovered that in the typical list-wise directed forgetting paradigm, the first to be forgotten list 1 is always followed by a list 2 that people have to then remember. And if you leave out that list 2, if you don't show people a to be remembered list after the list that they were supposed to forget, then you don't get a directed forgetting effect. There's only one published study that goes against that finding, a recent study by Rakshmani, who didn't have a list 2 following the to be forgotten list. Instead, they had another second list preceding to be forgotten list, and also found a directed forgetting effect. So this is a condition relatively similar to our high proactive interference condition. The remaining difference is that whereas Rakshmani and all other research in the directed forgetting tradition, they never gave an orienting task, whereas we of course did. And so maybe the orienting task helps to establish the words in memory in a more robust manner that prevents them from being forgotten, whereas in classical directed forgetting studies, that's not the case. But that's speculation for now. Now, at this point, I have a few more things that I want to show you, a few more detailed analysis from the experiments. I could skip those if we don't have time. What do you think, Edgar, Bea? Shall I continue for another 10 minutes?
We still have time. Continue, Klaus.
Okay, good. Then I'm going to show you a few more results that, well, they don't really answer the questions that the question that we are very interested in here now, which is how does the intention to remember actually boost maintenance in working memory? But at least these results give us some hints about the how. And these are now analysis breaking down the recall by serial position in the list. So serial position functions, as they are called. And I'm going to show you a few examples, because across the experiments, they all look alike. I'm going to focus, of course, on those conditions. I will call them summarily working memory conditions, those conditions where the intention to remember actually helps. So this is from the first 2 experiments, serial position curves for item recall. And what's conspicuous is that the intention to remember seems to help particularly the early list items. So whereas in the incidental and forget conditions, there's a marked recency effect. So earlier items tend to be forgotten most. That is mitigated by the instruction to remember. So the earlier items are saved from that forgetting. When we look at the position memory score, we see a hint of the same pattern, but it's less clear in these experiments because we see a primacy effect already in the incidental condition and the forget condition. Okay, here's another example of serial position curves. This is now from experiment 4, the immediate test for the set sizes 5 on the left and set size 7 on the right. Again, first, let's look at the item recall score, and we see again the intention to remember seems to selectively boost a memory for the first 3 or 4 items. So, right? Looking at the position memory score, this time we see a similar pattern also in the position memory score, with a larger effect of the remember instruction early in the list. Now, final set of serial position curves I want to show you comes from this last pair of experiments where we had these long lists, 25 lists, right? And so here we have again the item recall score for immediate and delayed recall. And here we find something very interesting. Remember, this is the experiment where the intention to remember actually had a slightly detrimental effect on item recall. And we see that here in the immediate test throughout most of the list, except the last 3 words, they actually benefit now from the instruction to remember. And this is the case only in an immediate test. It goes away in the delayed test. So this is exactly what we would expect if we assumed that the last 3 or 4 or so words of the list can still be maintained in working memory. And if memory is then tested immediately, then they can be recalled at least partially from working memory, and the instruction to remember boosts maintenance in working memory, but not in episodic long-term memory. Right? Now, for contrast, let's look at the serial position curves for this position memory score. So people's ability to remember the positions of the items that they were able to recall. Here we see, as we've seen before, a fairly big beneficial effect of the intention to remember, and that is now spread out over all list positions. If anything, it's even more pronounced at the beginning of the list. So again, the position memory dissociates from the item recall score. Okay, so what that tells us is that the effect of the intention to remember on maintenance and working memory seems to be through a boost to maintenance of the initial list items. So my idea about that is that working memory, if it doesn't have any reason, or if the person, I should say, it doesn't have any reason to maintain information in working memory, then every single word, as soon as it has been processed, is being suppressed or thrown out of working memory. And with every subsequent word, older contents are removed even more effectively, so that after you've seen 3 or 4 words, the first word is virtually gone from working memory. And that creates that recency effect. And the intention to remember the words mitigates that successive removal from working memory. But on top of that, we seem to have some additional effect of the intention to remember on these item position bindings, which clearly happens in episodic long-term memory. All right, that brings me to really the final conclusion slide. I think we have good evidence for our prediction that the intention to remember improves maintenance in working memory, but it doesn't have the same effect on episodic long-term memory because it doesn't help item recall. But that's an unexpected, unpredicted finding. The intention to remember seems to help selectively the association of contents to their context, in this case, their spatial location. Concerning forgetting, the intention to forget doesn't seem to weaken memory traces. So the good old directed forgetting effect, which is not in doubt, must have a different explanation. One that's on the table by Lili Sahakian's work is, of course, the context shift explanation. We could maybe add to that the assumption that you need a second list following the to be forgotten list. The second to be remembered list might be necessary to induce that context shift that splits off list 1 in your current mental context and makes it less accessible. Another potential explanation is that list 1 suffers from interference from list 2, and it suffers more retroactive interference from list 2 if you let it, which you would do only if you were instructed to forget it. So maybe that's the role of list 2 in creating that directed forgetting effect. But yeah, that's speculation. Yes, and with that, I'm at the end of my story. I want to thank you for your attention, and the organizers have asked me to put up this slide about how to raise your hand in the upcoming discussion, to which I'm looking forward. Thank you.
Thank you very much, Klaus, for a very stimulating talk. I guess there are a lot of comments or even questions. So you have, as you see on the slide, 2 ways to pose questions. One way, and that's actually the way we prefer, raise your hand. We will give you, we will unmute you so that you can raise your question and Klaus can answer. And the other way to raise a question is just to put it into the chat. These are the two options. So are there any questions right now? I see already one question. I think Martin Brandt was the first one. Bear, would you please unmute Martin so that I don't have to care for that?
I think I'm unmuted. Can you hear me?
Yes.
Yeah, perfect.
Okay. First of all, thank you for your inspiring talk. I have a very simple question. I'm quite sure you will have received this question before. How can you be sure that in your working memory tasks, you only measure working memory? Because subject has to study 5 words, do an orientation task. You said they need about 2 seconds to give an answer. And later on, they have to give the positions of the words. So it's a lot of time. So in my eyes, there should be a contribution of long-term memory to these tasks. And is it critical? I've not thought about it completely, but how can you be sure that there's no long-term memory contribution?
Well, in fact, I'm pretty sure there is a contribution from episodic long-term memory in all these tasks. I briefly mentioned earlier that the ideal working memory test with no contribution from long-term memory, I'm not even sure that exists, but I'm pretty sure that with words as materials and, as you said, relatively generous time for engaging with each word, there is a substantial contribution of episodic long-term memory to recall. And that's why even in those conditions where I assume working memory doesn't contribute more than negligibly to performance, that's the incidental and the forget instruction conditions, where I assume that working memory basically is empty, if you want, or doesn't have much words. We still get performance on a fairly decent level. I venture that that performance basically reflects the episodic long-term memory contribution to all these memory tests. Yeah. And I mean, you asked, is that critical? I don't think it's critical for the rationale of our conclusions, because I'm looking for an additional effect of contributions from working memory on top of what episodic long-term memory contributes to performance. And that additional effect on item recall we see only when we have the intention to remember and we create conditions where working memory can operate effectively.
Okay, thank you very much.
Sure.
Okay, thank you. Then the next one to raise a question is David Martinez. Maybe, yeah.
Yes. I'm wondering about the role of strategies in this task or in these experiments. So when participants are told to remember something, wouldn't that affect their strategy use? So whether it's subvocal rehearsal or more elaborative rehearsal?
Well, I would assume that it does affect their strategies, though, of course, the orienting task made sure that regardless of instruction, people engaged in activity that we know is already establishing a fairly good, at least episodic memory. And also, they didn't really have much time to engage in additional strategic behavior, because whenever they clicked the button to enter the response to the orienting task, the next word appeared already, right? So, for instance, you mentioned rehearsal. We know from studies from Jeff Ward's lab, and we replicated that, when you ask people to rehearse overtly, right? And people can do that, they do that willingly, and then you know exactly what word they rehearse when. When you present them the list at a pace of, say, 1 second per word, then they cannot rehearse more than the last word they saw, right? They just don't have the time to go back and rehearse the entire list cumulatively, so they don't, right? Now here, they got a bit more than 1 second per word, but that's because they also had to do the orienting task, right? So I don't think people had any significant amount of time to rehearse the entire list. and not to speak of further elaboration, which is even more time costly. So I don't really see much room, just time-wise, for people to add a lot of strategic behavior. And also the fact that whenever we create conditions that are close to typical long-term memory tests, the intention to remember makes no difference at all for their memory, indirectly confirms that they didn't, when instructed to remember, engage in any, at least not any effective strategies with respect to episodic long-term memory.
Thank you, Klaus. Then the next one to ask a question is Beatrice Kuhlmann. Bea.
Yeah, thank you. Thanks for this interesting talk. So I maybe have a egoistic question. I was curious because I'm interested in the separation of item and source memory. And so I see that here in the item versus position memory. And so I was curious, the full pattern, I guess. So you had one study where the delay with the mental arithmetic task of 1 minute didn't affect the position memory. And that's very much in line with the neuropsychological theory that source or position memory is represented in the hippocampus and thus should be better protected from interference. But then I wasn't sure later on, it seemed like you also observed some delay, and I assume it's always an interference-filled delay you use.
Yeah.
I'm not sure if would you say that in general, it seems that position memory is less affected? And connected to that, I was curious how you score the position memory and how you ensure to score that separately from the item portion of the task.
Yeah, so to begin with the last question, the position memory was scored as the proportion of correctly selected positions out of all position responses, which is out of all the items that people had initially typed. Right? So if people typed 5 words, and let's say, okay, out of those 5 words, maybe 2 were not even on the list, so they are discounted. The remaining 3 words that actually came from the list, out of those 3, how many were allocated at the exact right position? Right? And that had to be exactly the original position. So if 2 out of 3, that would be 66% position scoring. Now, the effect of the filled delay, and yes, it was always a filled delay in most experiments, arithmetic, except experiment 6, where we had this letter span task. It always had a relatively benign detrimental effect on memory, and it was about equally benign on item recall and position memory, although I never formally compared the 2 effects, which is a bit difficult because it's different dependent variables. I wouldn't even want to run an ANOVA or something like that on 2 different dependent variables. But just in terms on the percentage correct scale, it looked all in the single digits percentage correct wise for both scores.
Okay, thank you.
Okay, then Arndt has a question. Arndt Bröder.
Okay, thank you very much, Klaus, for this talk. I have a question which you probably only can speculate about, but you found this boost effect of the remember thing on the position memory, and you once called it context memory. And my question is, would you expect this to hold for other context associations as well? I know it's speculative because you haven't tested, but maybe you have an idea or a theoretical idea whether this would also hold for other context variables or context.
Well, if I had to bet some money, I would be willing to bet a decent amount on temporal context. So if we had presented the words centrally on the screen and then asked people to indicate us retrospectively whether a word was the first in the list, the second, the third or so, I think that would show similar effects, simply because I think that with verbal materials, when we ask people to indicate the spatial position, what they actually use is the temporal ordinal position, which is fully confounded with the spatial position in our experiments. Now, going beyond that, contexts like, say, print color or voice for oral materials, for spoken materials, I don't know. No idea. I wouldn't have any good theoretical reason or empirical reason to speculate one way or another.
Okay.
Thank you. Thank you, Klaus. Then the next question to raise is by Manish Kumar Thana, who already had a question during your talk. I mentioned in the chat, but maybe she can now return to that question.
A very nice presentation. Thank you so much for this wonderful talk. And I think you have shared so much insight from classical studies also. I'm just wondering, and I'm sure that people might have asked you this question, what is the effect of arousal on this proactive interference? I mean, the words which we use basically are neutral words. But what would be happening if we consider the arousal level, not only on intention to remember, but also on intention to forget? And another follow-up question is that, as you mentioned in your talk, that orienting task might be the reason that due to some reason there is a change which one could anticipate. Is it like orienting task behaving like release from proactive inhibition, which we can say that there is a category change, and then when the category changes, then there is a sudden release from proactive inhibition? Yeah.
Yeah, these are both interesting questions, but I'm afraid on both of them, I don't know any data that I could base my answer on, right? Again, starting with the second, because there I feel a bit more confident that, yes, if from one list to the other, we change the orienting task in a fairly substantial manner, I don't know, maybe in the first list, asking people to make pleasantness judgments, and then in the second list, do the Savannah survival scenario, which puts them mentally maybe in a very unpleasant situation, stranded in a savannah with no food or water. Maybe that's a big enough context change to create an effect like Lily Sahakian and her colleagues have documented that looks effectively like a directed forgetting effect, impairing memory for the first list. So yeah, again, I don't know it, I haven't done it, but I'd be willing to bet some money on it. On the effect of arousal, well, I haven't followed the literature on arousal and memory very closely, I must confess. From the little that I've read about it, the effects are fairly subtle and not terribly consistent across experiments, and nobody really understands them. Correct me if I'm wrong, but that's my impression. So yeah, based on that shaky knowledge of what I believe is a shaky empirical basis, I'd rather not venture any speculation.
Thanks, Klaus. There's a question by Yasmin Kirzlimak posted in the chat a while ago. I think we should turn to this question. Do you think that the intention to recall could have no beneficial effect on serial position recall for long-term memory in elderly adults? It seems like it could represent some sort of dual task, more cognitive effort for keeping the positions in mind during the distractor task, which elderly people might probably be worse at. I think this is reasonable, isn't it?
It is indeed. It is indeed. Though keep in mind that even the group who we instructed tried to remember the words. They were not instructed to remember the positions of the words. So one could say paradoxically, we see an effect of the intention to remember on episodic memory with regard to the one aspect of the material that we did not instruct people to remember. We just told them to remember the words. And whenever they went through 5 trials, which they did in what we call the high proactive interference conditions, including the last 2 experiments, when they went through 5 trials, and they were in the instructed remember condition, for the first 4 trials, they were only tested for the items in the free recall test. And the position memory follow-up test came as a surprise for them too, right? So I don't think that they actually invested any effort into specifically remembering the positions of the words. And so to answer your question, I see where you're coming from. There is this quite well-supported idea that in old age, it's binding memory that is particularly impaired. I would think that that should also impair incidental binding in episodic long-term memory in older age. And if anything, if you intended to maintain these bindings, that might actually enable older adults to somehow find a way around that binding deficit and mitigate it to some extent. Although, again, that's speculation.
So I just saw a raised hand by Jasmine. Maybe I give her the word right now because it relates to the question I just posed, right? Jasmine.
Yes, thank you very much. Yeah, I find your explanation quite reasonable. I unfortunately missed the first two experiments. But so could it be that when you generally have the intention to remember, you kind of include more, like you said, binding wise, you include automatically more contextual aspects in your encoding, like, for example, the position automatically without intention. Could that explain it? This way, I would automatically assume that people with less cognitive capacity because of, classical findings like the aging effects you can see in the literature would automatically reduce this effect, this serial position effect. I mean, there is this finding that the elderly are, particularly profit from incidental and long-term memory encoding. So do you think that could be a source?
Yes, I mean, it's possible that position memory is improved. I mean, it's very likely actually that position memory is improved when you change the context, let's say the temporal context, from one word to the next more, right? So that would certainly help to mentally separate the words from each other on whatever context dimension you use. Let it be temporal or spatial context. If you intentionally did that, that would improve the ability to then identify the right position of a given word. That said, I wouldn't know why a person instructed just to remember the words should engage in such a strategy, right? Because again, they were not instructed to remember the position for each word. And changing the mental context between words intentionally more than you would otherwise do, yes, it separates the words in memory, but it also changes the context between the list initial words and the context that you end up with at recall more, right? So it induces the kind of context change that Lily Sahakian argues is responsible for the directed forgetting effect. And she experimentally demonstrated that when you mentally change your context between encoding and recall, you forget. So overall, it doesn't seem like a smart strategy to me to introduce a lot of context shifts between the words when you're instructed to remember the words. But apart from that, your second part of the question, of course, is well taken. In many circumstances, I imagine that older adults, they have trouble implementing the intention to remember, especially when they are in dual task situation and have too many things to do at the same time, like an orienting task plus the intention to remember. It's just that in this case, with regard to position memory, I don't think that explains it. But with regard to the item recall score, I could see how older adults might benefit less from the intention to remember compared to the incidental baseline than young adults would.
Thank you very much, Klaus. Then there is another question by Uli Glovala. Uli.
Let me see. Do you hear me?
Yes,
I hear you.
Wonderful. So everybody told you you gave a great talk. I liked it a lot. So
Thanks.
that's apparently a tradition. Now, I do not know whether that relates to what your research at all. I've done some research in memory for text and comprehension for text. You may have heard of that, these story grammar models and all that kind of stuff. And when people ran these experiments, the position in the hierarchy actually related very well to the quality of the memory. And then some silly people started to do very, very long retention intervals. For instance, they asked people to memorize the contents of a movie or a novel they read. And if you look at the protocols of these reports of the subjects, then you almost find no evidence of these structural hierarchy models at all. Mostly you find kind of weird aspects of the story or things that relate to their personal life, which they find make a movie or a novel unique to them. This is, so to speak, what remains. What one idea that I was putting forward is that what we have taken for a memory model, a model for what we encode in memory, is much more a model for the encoding of the information. Sort of, we use these informations about how stories are built, that there is a plot and there is to be a goal and there are some obstacles and all that kind of stuff. We use that to understand a narrative. But sort of the generic information that's being presented in a narrative, we simply forgot because it doesn't matter. It's a crime story, okay? There is someone who has been killed. In the end, they find the murder, period. This is not worth to remember in my long-term memory. What's worth to remember is something which is unique of one of the characters or the situation, or if there are places I have been to and all that kind of stuff. I know it's compared to the retention intervals you are looking at, this is really spacey. And you can say, only this has nothing to do with what I'm doing, but have you ever thought of that the assumptions concerning memory may be more assumptions concerning processing? For instance, if you would look at the retention of the larger word list, the 25 word list, I would predict that quite a few smart people, actually also older people, not everything is getting bad with older people, they immediately create a story of what you present them. They try to, at least they try to form a story that integrates the more or less random information that you present. So what they remember then may be snippets of this story they have created, but they wouldn't know which words actually you've used. They would use synonyms and they wouldn't remember the positions. So, I mean, you have to do a lot of subjects to collect data, but perhaps it's worthwhile to consider at least once to look at considerably longer retention interval, in particular to the episodic memory part of your experiments. Just as a proposal, idea, I don't know.
Yes, thank you. I want to respond to several aspects of what you said. One is especially with regards to older adults. Unfortunately, we've just done a few studies. Leah Barge was the lead author on those, looking at elaboration in young and old adults. And quite disappointingly, the older adults, although they do try to elaborate, they don't benefit that much from elaboration compared to the young adults in their episodic long-term memory. But then again, these are relatively short retention intervals. So you're right, for a more complete understanding of long-term memory, episodic memory, we should also look at longer retention intervals. I must say, I'm very surprised about what you say, that people, when asked about memories from days, weeks, months ago, don't remember the higher level structure of stories better than ancillary details, because from a functional point of view on episodic memory, I would have expected that episodic memory preferentially maintains what is most likely to become important in the future. And when I experience an event that I interpret while I experience it as some coherent storyline, as it were, with causal connections between what happens, social connections, then I imagine that the overall plot, at least of a real life event, is what's most important for potential future applications, like who did what to whom, why, compared to arbitrary details like what colors of shoes did X wear. If that's not the case, that would put in doubt my my sort of premise that the memory system has evolved to do its job optimally. Now, perhaps one reason is that when you ask about movies and novels, they do have a coherent story plot, but that story plot is totally detached from the person's actual life, which is, of course, what actually matters to them, right? So as you said, what happened in the crime story, the story plot of crime story really doesn't matter for their life. A story of a crime that they did experience themselves, that's, I think, a different matter. Final aspect of what you said about longer retention intervals. I'm pretty sure that our finding about episodic long-term memory not benefiting from the intention to remember, I'm pretty confident that that also holds over retention intervals of weeks and months. Because, well, if episodic long-term memory did not work incidentally without our attention to remember, then we wouldn't have much memories left from weeks, months, and years ago, right? Because we go through our daily lives usually without the intention to remember what we experienced.
Yeah, that's true. I agree. But for instance, one manipulation, well, let me perhaps correct a little bit. People can, of course, tell you the details of a generic plot of a crime story, but that's not necessarily the plot of the story that is being talked about. We have formed a pretty generic idea of such a plot, and this interferes very much to what they actually read or saw. So perhaps that adds a little bit clarification to what I tried to convey. One idea, if you have these 25 word lists, why don't you use an instruction, try to form a little story of these words and manipulate the ability of doing that by giving more congruent word lists or incongruent word lists. That may create some completely different effects on the long-term memory instruction tasks. I don't know, maybe. So at least whenever I look at data in, I usually do serial position experiments in my lectures with 20 or 30 words. And those students who remember a lot they typically create a little story from the word list they receive. Those who just try to maintain the words, they're pretty bad in their memory. And they're pretty good at memorizing that for a couple of days. Of course, then it tends to be gone. But that means they use the material you present to memorize something different than you presented.
Sorry, I lost connection for a minute or two in between.
What a shame.
So maybe if you could quickly repeat.
Very simple. I refer to experiments that I typically do in my lectures. I do the serial position effect with hundreds of students. And when we analyze these data, there's a marked difference between quite a few students who create a story from these words online. What they memorize then is the story, and of course they can retrieve a lot of words. The other students who are not engaging in a memory technique like that, they show the typical effects of primacy and recency. The others, they present their story and that's it. They could read many words. And this actually for a couple of days, perhaps not weeks or months, but so what they have done actually is transforming the input that you have given, 25 words in the serial list, to another kind of quality, namely a reasonable story for them. And of course, it's a lot easier to keep that in memory than to memorize the positions of individual words in a list.
Yes, I think that's the well-documented beneficial effect of relational elaboration on episodic memory. And of course, if you look at a single list, that destroys the serial position curve. I guess if you did that for hundreds of lists, then the usual serial position effects would re-emerge even then, because then you average across the peculiarities of individual words and how well they fit into the story.
There's just one more item. I made a suggestion to try to use 25 words that are easily connected to a story and compare that to situations where it's pretty odd to form a story. That would create, I suppose, different effects if you look at longer retention intervals.
Well, yeah, it would create a main effect.
Yeah.
What else?
The position effect would be gone.
I doubt it.
You doubt it?
When I average across many lists, I think it will re-emerge, yes.
That's a good idea for an experiment. One's A and the other is B. Well, thank you so much.
Thank you.
Maybe a very short and simple question. So you showed convincingly that remember instructions are a simple way to boost maintenance in memory, right? So, but we have such a simple manipulation that boosts one function of working memory. And if working memory capacity is limited, and we all agree on that, there must be another side of the coin. There must be detrimental effects of this treatment on other functions of working memory. Have you done any research on that, or can you speculate on what the other side of the coin will be, where the drawback will be of this method? Or is the reasoning wrong? That's also a possibility.
Well, the way I see it is when we typically test working memory and measure its capacity limit, then we tell people to remember, right? So we motivate them to use their limited working memory capacity to the full. When we don't give them that instruction, then they're not going to use their working memory capacity for the memory task we give them, and instead engage in whatever daydreaming. Now, of course, intentionally maintaining information in working memory means that you're going to use your limited capacity for that information. That the cost that you mentioned is that then you have no capacity left for other information, right? So the intention to remember, the instruction to remember, is not in any way a means to expand the working memory capacity. It's just a way to make people use it on the task that you want them to use it for. I don't know, does that go in the direction of your question?
Probably a drawback of using that would be that the attention you can direct to new incoming information is somehow limited. In other words, while engaging in maintaining information in working memory, your ability to process new information is limited. Would that be possible?
I don't think so, actually, because I don't think that maintenance in working memory involves continuous attention. And in fact, people can maintain substantial amounts of material in working memory and then in the retention interval engage in a totally unrelated processing task. And if that processing task is really unrelated, then they can do that processing task just as efficiently as if they had no working memory load.
Thank you very much, Klaus. Looking at my watch, I see that the time is definitely over. We have to stop right here, but not before thanking you once again for this very stimulating talk and for your willingness to answer all our questions and comment on these issues. I learned a lot today, and I think many people participating also. So thank you for being here, and we all enjoyed it very much.
Thank you. Thank you for joining. Thank you for the discussion, for the questions.
So before we leave today, we should probably point out our next meeting, but I have to admit, Beatrice, I don't have our schedule on my desk right now. Can somebody help me and tell us?
So we'll be on spring break in Mannheim for the next 2 weeks. And so our next meeting will be on April 13th. And we'll have Anne Cleary on metacognitive sensations of memory lead to recollect, do these lead to recollective confabulations. And keep in mind, Germany is switching to summertime this weekend. So after the Easter, we'll be on Central European summertime. So check your time zone. April 13th, we'll be back.
Okay, that's it. Thank you for participating. See you again in a couple of weeks. Bye.